energy can grow. So we have lots of energies to get so and then we enjoy. And then today we have three talks, keynote talks, and the first keynote talk will be delivered by Dr. Sakti Swami, IIT Bombay, who will talk on the terminal for the new as an Indian RE landscape. And so I request Professor Ruti Rai and Dr. Fredis to be chair and co-chair of this session. I request that. I request Dr. Gyana to facilitate with Lord Lucas to our chair. And now I request to Dr. Lucas to facilitate with Lord Lucas to our time to start our lesson, so I hand over this place to our chair and co-chair.
Good morning, everyone. It's a wonderful morning here in BHU. Very pleasant weather outside and inside too. I believe it's going to be a wonderful morning session. Second day of this COVID event, which is workshop, brings a lot of knowledge. I could not come yesterday to some other work, but I'm sure today I'm going to be learning a lot of things. At the outset, I would like to thank the organizers, especially Dr. Alok Kumar, for inviting me to be part of this workshop. And I'm extremely happy that I have to introduce a very coveted speaker this morning, Dr. Shakti Chinmaswamy, who is here from IIT Mumbai. He has a lot of experience in the field of not only RE, but many important elements like gold and magnetite. He has been to South Africa, as well as he has spent time in Switzerland. He has Sweden, and has a distinguished accomplishment in the fields of economic geology. Although he hails from Trishapalli in Tamil Nadu, he has been working in North India as well. He has amassed a wealth of expertise through his academic journey, culminating in a PhD from IIT Kharagpur, currently an associate professor at IIT Mumbai. Dr. Chinmaswamy has dedicated over 2 decades to pioneering research in economic geology, focusing notably on the genesis of orogenic gold deposits and magnetite ore systems. His contributions extend globally, from Sweden to South Africa, where he has built complexities of mineralization processes. His groundbreaking studies on ore fluid dynamics and geochemical analysis have been playing a pivotal role in advancing knowledge of mineral deposits in India and beyond. Dr. Chinmaswamy is currently pursuing research on critical mineral exploration and genesis in India with a focus on rare earth elements, cobalt, and lithium. Dr. Chinmaswamy's work not only enhances geological understanding but also promotes sustainable mining practices, exploring his role as a leader in the lab. He would be talking on a very significant aspect that deals with the existence of various deposits of rare REs as well as other related elements in the Indian continent, where we have the so far very limited exploration in this field. So his paper is going to be one of the landmarks in establishing and showcasing the occurrence of these deposits in India. I invite Dr. Chinmaswamy to please present this.
So, let's start with the program.
Yeah, please.
Yeah. So, good morning to everyone. So, thank you, Professor Gujira, for a nice introduction. Good morning to everyone. I thank Dr. Alok for giving me this opportunity to talk in front of you. Importantly, I feel honored to give this lecture in front of my guru, mentor, and my PhD guide, Professor Vishwadeep Mishra. So, with him, I've learned a lot. I owe to him. So, whatever little knowledge I gain, it's because of him. Coming from a small town to IIT, I was immature and very humble guy. Joined with him, and he trained me more than me personally and also professionally. So, but coming to the talk, topic of talk is in our workshop. So it is a critical mental. Topic like critical minerals for new age. India's RE landscape. Being originally I got a course in my PhD, and after that, a little bit work and mathematics with uh, started. So now I'm around the last 3-4 started doing this, and 2 students of mine working in rare and copper. So I thought learning I did in a couple of years and students here, instead of going what I kind of learning for the students. What is the critical methods? How criticality of measured? What is this criticality matrix? And then list of critical methods for India and other countries. Other as a critical metals or minerals and rather than their characteristics, different types of rare deposits and rare potential in India. If time permits, I will also discuss with some others critical metals and what are the on critical metals and IDB and just deal with it. So you had this is you might have gone 2 days of brainstorming sessions with a lot of knowledge you might have learned about rare earth. So maybe you can think it as a refreshing contents. Yeah. So critical metals. So rare and study are now metals. So why these critical metals? If you see, India has got an ambitious plan from our honorable announced Mitra at conference of 26. The next, there are some ambitions like plans to the neutral net zero. So we leave no trace of carbon so that we can. So we need this green energy transition. So just give a definition. It is the global shift of fossil fuel from fossil fuel to renewable energy sources like solar, wind, hydro, and geothermal biomass. So this is essential for mitigating the climate change. Climate change is because of the greenhouse gas. And this is because the climate change is temperature rise, sea level rise, extreme weather events, ocean acidification. We are losing some of the biodiversity and health risks for the human and the ecosystem. So, to transform the society. So, climate change basically. So, transition from non-renewable to the renewable-based production, the energy production, storage, transmission, and use of this energy. So, energy is very important. Russian scientists produced what we have is civilization type 1, 2, 3. He made a scale, and that civilization classification is so production, storage, and transmission of this energy. So you can click on or on this I will tell. So there are three types of civilization. So type 1, 2, 3. We are not even type 1. What is type 1? Type 1 is to control the energy, whatever available within our planet. And type 2 is control the energy, control or manage and produce energy. So, yeah, let us go around scale. Suppose this scale. So type 1, 2, 3. So we are, not even type 1. We try to like what we are most of it. Reverse, we can things and we can control this natural energy. Like control the earthquakes and volcanic eruption and so on. So we not even reached type 1, we are even 0.7 at that scale. Similarly, consume stars energy, like solar energy surrounding this all the energy from there and try to consume. Type 2 civilization and type 3 civilization is get the energy from the entire galaxy. So our civilization is basically how to control the energy, how to produce and manage it. So he thinks that saying here this scenario manage this energy, and we need to green transform into green energy. So we need to have changing lot what is happening, and we need to have the green energy. So transition from fossil fuel to renewable to non-renewable, renewable to renewable energy. So we have highly developing. So we need to have sufficient from this geology can do that, but not fully. So partially yes, but we need to find out more amount of primary items, so critical metals. So this diagram, the energy transition sectors, where you have all this renewable energy, technologies are there, e-mobility is there, high-tech industries are there. For various kinds of materials are, so they are all connected. You can see here. So particularly rare earth has got very supply risk, high supply risk. Like this, high to low supply. So metals are other way it's connected with the green energy transition, and rare earth is very important. That is very highly. And what is critical materials? Critical minerals, critical raw materials. As per the US Department of Energy definition, any non-fuel mineral elements of or material that high risk in the supply chain disruption and essential in one or more energy technologies, including technologies that produce, transmit, store, and conserve energy. So there are two here. So one should have a supply chain. So if there is a disruption, there is a problem with the supply risk, and then it serves an essential for a particular or indirectly the economic expansion, so economic importance. So material is deemed critical. It's the economic importance and supply chain reliability. So these two parameters are important to define critical metals. The challenge what we have in this critical metals is actually the concentration or the occurrences. Because they are all in trace. Next is the extraction and processing metals. Again, they are on very low quantity and they are occurring in very few geographical locations. So there may be a supply chain vulnerability and disruption. So, countries came up with a list of critical mineral materials, like US and European Union. India also did this last year and came up with a list of critical minerals. About 30 critical minerals are very biological occurrence. So the need of our is more in, to develop mines. And what is criticality matrix? So if you see here, axis you have a supply risk, and the y-axis you have an importance to energy or economic importance. You can divide it into four: low to high, very low, low, like this. So the highest risk and highest importance classified as the critical. This the US and this kind of on this. And this is change geography. An example from again, how it's been calculated. Economic importance and supply risk, which gives you the criticality of the metal. Economic these parameters, so disruption potential, substitution index, and GVA. GVA is gross index. So these are used importance. And then we have a supply risk. Supply risk is governance parameters here. So these two are calculated with that this kind of equations. So there are some parameters which calculate the criticality assessment. So I'm just trying to give a brief idea of it. So we have a critical. So that really, and what is that effect of this that entry? A and Q. A is the share of the metals consumption in that sector, and Q is the GVA. Right. Multiplied by the index of the substitution. Suppose with the substitution, so that's kind of the substitution index. And if you have in one sector, all the sectors. So for that particular critical mineral, the country level, the what are the governance, if there is a with respect to this reflects the risk and the supply of a particular raw material. Index is very important. Principal Fishman Index is a worldwide governance indicator. Is a this is very important for criticality. How criticality of this element is given. Important critical method is companionality. So, what is companionality? As per Nasser et al. And so, if there is a companionality wheel, there are some certain critical, away from the center to the ring. If you go away from this, there is decreasing companion of. So, there is this to by the geological occurrences and their chemical affinity. So, if you see nickel deposit, always you will have a cobalt. It's a kind of a co-product. So if there is one metal, there is another there is a seven times some problem with so seven times there is calculations based on predictions and how required what it. So if this various and this coming here, so new and onshore wind. So in the green energy transition, this earlier recycling is not enough to get the meeting our. So these are the critical mineral list of various. Okay, for India. So this is the list of critical which Japan. So these are which the critical research on knowledge and 2017 we need to process. This I'm going to focus on because as a geologist point of view, this we can focus and others like metallurgy and the we can vast and rich in yeah, wide range of mines are there. Are we missing something or to find out? So we need to do a rigorous exploration study to find out critical deposits. But a lot of scopes are there if you do a rigorous exploration. Because of the time availability, because students have just resource and reserve. So we need to have as a reserve in a quantity, and it has to be in sufficient. So the concentration of this, importance of the chemical process, the particular part of the earth. crystal chemical process which leads to the high concentration of these metals in a particular part of the earth so that we can mine it profitably. So how many of you have you heard of petroleum system concept? I'm asking this to you. Okay. So if you the ore forming process, this is like the ore forming process can be very simply explained. And the metal source and the migration pathway and the depositions. The process given. So most of this, I take class I have seen. So he tells that it's telling there are two types of deposits, one magmatic and non-magmatic deposits. So magmatic deposit, even in the magmatic deposit, there are some action of hydrothermal fluids. Even action in the Kiruna type, there are fluids. So most of the deposits are enriching of metal is very the heat source, they had a metal source and fluid source here. The petrochemical process makes it to be concentrated in a particular part of the earth because came from the hydro. Then how much it's used, various industries they acquire rare earth elements, and what are the supply of the REs? The world supply is a major supply, and that is the RE supply here. India is there here with the so yeah, it's here. So have, we have a lot of resources. We need to find out. Have is the world is rare earth research. And although it is research, most of the things are coming from our places, but not from the primary rare earth deposits. Many rare earth primary deposits are there, none of them is mined. Not yet, but this reserve is coming from the beach places. So demand in the areas are very high, so we are relying primarily on the imports from China. So it is giving about 200 billion to the Indian economy, and with the increase in technology and demand in the green energy transition, this is going to be very high. So you might have other elements. The students, okay, no or yes? No? Okay. I say yes. You say you defend it? Yes. If you say other metals like gold, it's rare. Cesium is there. Okay, so sorry, cerium. Okay, so you have gold 0.04 ppm crystal abundance. But if you see the solar system, rare of this question. Okay, so very rare. So in the cosmic point of view, so there are some this so the lanthanol is scandium and yttrium. So with this, by auto fusion. So the contraction. And contraction is not is because the ionic radii is actually decreasing like this. Where when there is a melting, increase and they form values. So rare what we are talking about Milani rich deposits, not HRE. Very rarely we get the HRE. Very minerals, challenging minerals we know which contain rare earths. And other related 14%. So major are here. There are many minerals, and so on, but these are the chemically extractable, like basnasite, pyrrhizite, and synthesite, and monazite, and so on. So all these are economically extractable. So although we have a very metals we found, these minerals are so again, so these are there are more occurrences are there. So in monazites, India is there as a beach places. So although some of the deposits like Kamatai and Ambadonga, so not getting into this place because we are not yet to one of the states. So the way from places anorogenic and point rocks, and so this two different tectonic environment about rare earths. So in Sweden, it is the hydromatic deposit with the drift basins where there is an influence of this continuous source of rocks, and also post orogenic rifting where there is a entries, not only the but also the secondary during the localization process. So rare earth elements can be divided into there are primary and secondary deposits. So there are some carbonatite hosted. So these are like granites and pegmatites and sub-2 metal. So we knowing that parameters and aluminous details, so it shows this, some of the data from my, I brought it here to show metaluminous, paraluminous. The secondary deposits. Deposits are, so these are also some of the type RE, special type secondary. These are maybe have RE deposits finding out to be extract because they deposits. So hopefully I can discuss some of the deposits. Writing I made it. I just put it in a bullet point in of these deposits. Quickly I will explain to the student point of view again. Cooperative are the major source of revenue, and about nearly 50 is the one, and not only no, sorry, the high concentration of light and rare earth elements are there. You have selenium and all these elements. We have very carbonate rich minerals of, and this is one of the rare igneous rocks. 50% of carbonate minerals are there, mostly calcite and dolomites, and RE concentration of all igneous rocks. So that's why they are very important. So we can have at least 3 of this carbonatites in aquatic deposits in the Mount deposit in California. And then lead magmatic fluid metamorphism in Vianagogo, deposited from China. And then there are some super thin enrichment of weathering of this carbon texture, which is in the. There are some other deposited produces diagram, okay, and then carbonates are not only for this phosphates, iron, chloride, copper, titanium, uranium, and calcite. Among carbonates got a very economy of it, and as it magmatic and hydrothermal enrichments. So it's enriched in these carbonatites, and basmasite is a major mineral which so this fractional crystallization and the enrichment by the hydrothermal fluids and whether it's lifting settings during orogeny and so maybe we can put India, there are two. So all others from USA and Africa location as given. And the one the exploration targets. Coming to the second type, this alkaline, paralkaline igneous rock, these are another important which host this acidic saturated. They also occur in the Mesozoic is in but they are definitely cyanide rocks, paralkaline granitic rocks, and paralkaline felsic plastic rocks. And yeah, so 10% of this is containing the black minerals. The key are bearing early extraction is challenging. So this paraluminous, metaluminous, you can just understand how this is defined. This is again from we have a paraluminous. Biotech very important, but particularly so also have water which makes kind of rare metal to be so and the metal perforates the process is crystal metal fractionation and constitution is zone refining. The zone refining of the pegmatites which due to the rare fractionation make this metal to be concentrated. RE deposits, ion absorption deposits. Here, they are in the weather granites. So there is a particular type of deposit. There, the weather portion of this specific type of granites, which is about 50% of iron containing iron RE and lithium. In China, so it's related to subduction related. So there is a specific type of RE deposits is being identified and particularly occurring in certain places. So granites are and muscovite bearing, paraluminous to weakly paraluminous, and they are highly silicated.